Now you're going to find that I use games a lot in my teaching. It helps to connect with students. It also helps as a method of review. Give me just a second, man. One of your classmates is he was there and then he's gone, so he may come back in a second. That was Mr. Lopez, one of our regulars during third block. But as I was saying, I use games because games help me connect to students, and they also help me understand how you're working up here in ways that math problems don't always provide that same insight, because sometimes math intimidates students, sometimes it alienates students. It produces a lot of different negative reactions, but for the most part, most people respond fairly well to games. So I like to use games to do my teaching. Now, one that I use to introduce everybody, both to me and to the way I do business, is a game called 21. It's a counting game, a little different than the card game, a little different than the basketball game, if you've ever seen those forms of 21. In this one, you and I are counting against each other, if you will. And the only rule to the game is you can say one number at a time or two numbers at a time. So if I start the game and I say 1, then on your turn, you can say 2, or you can say 2, 3. Then I would come back and say 4 or 4, 5. You come back and say 6 or 6, 7. And we're in a race, if you will, to 21. And whoever is able to say 21 is the winner. Would you like to give it a try?
Sure.
Oh, okay, then I will start the game, and after Alexis joins us, he's an experienced player. I'll play you a few games, and I may give Alexis a chance to play you as well. So I will start the game by saying 1, sir.
2, 3.
All right, 4.
4. 5.
All right, 6.
7, 8.
9.
10.
11, 12.
13, 14.
15.
16.
17, 18.
19.
20, 21. All right, let's run it back, and you get to go first this time.
1.
2, 3.
4.
5, 6.
7, 8.
9.
10.
11, 12.
13, 14.
15.
Wait, what did you say again?
I said 15. 15. Did you hear me?
Yeah, I said 16.
Okay. 17, 18.
I lost 19.
Yeah, 20, 21. All right, let's run it back one more time. I'll go first. 1,
2.
3.
4.
5, 6.
7, 8.
9.
9, 10, 11.
12.
13, 14.
15.
You said 15, right?
Yeah, I said 15.
16, 17.
18.
19, 20.
21. All right. So can I tell you what I just learned in playing you?
Yeah.
All right. If you hadn't told me that you like math, I would say, hey, I think Luis likes math. And I also learned that, hey, Luis has never seen me before, but on the first day of class, I asked you to indulge me and do something with me, and you did it. So that tells me that you're at least open to fellowship and the type of fellowship I'm trying to create in here. So these are all good things. Now, I'm going to tell you some good news. I have lost in this game. I have lost, I would say, around 35 times. And I think I have lost maybe to 32 different students. That means there are some students out there who have beaten me more than one time. And there are two ways to beat me. Now, one way is to simply memorize the pattern of the game. So if you play enough games, you'll memorize the pattern very easily. The other way, though, is to lock on to the math underneath the rules of the game. If you understand the rules of the game, there's a mathematical principle that will unlock the key to victory much quicker than memorizing the pattern. But either way is a useful way to get to victory, if victory is what you seek. So I pull it out from time to time. Now, for the most part, we've worn it out with most of your classmates in the first 3 weeks, so I probably won't bring it out a whole lot, but I like to bring it out on the first day because that is the best way for me to put my best foot forward with you and kind of show you how I do things. So how are we doing so far, man? Are you going to stick around?
Me? Or,
Yeah, you. Yeah.
what do you mean stick around? Like stay here?
No, I'm saying, have I done anything that makes you say, oh my God, let me run away from this man?
Oh, no.
Okay, good, good. Then I would like to introduce you to Alexis. Alexis is one of our regulars here during third block. How you doing out there, Alexis?
Good.
All right, good to see you, man. You want to give me a quick game, or would you like to play Luis?
I don't mind. It don't matter.
All right, then Luis, Alexis, I want y'all to square off. Alexis, you may go first whenever you're ready.
1,
2,
3,
4,
5, 6,
7,
8,
9,
10, 11,
12,
13,
14,
15, 16,
17,
18,
19, 20.
21.
All right, good job, Alexis. Let's run it back and let's allow Luis to go first, and then we'll move on to something else.
1,
2,
3, 4,
5, 6,
7,
8,
9, 10,
11, 12,
13, 14,
15,
16, 17,
18,
19, 20.
21.
All right, good job, good job. And Luis, Alexis is helping you because he's giving you a few more repetitions. Because the more you play, the more you will start to understand and identify the patterns of the game, and that will lead you to success and victory. As you see, Alexis, knows some of the pattern. He's learning some of the patterns. There's still more to learn, but he is learning the pattern to the game. So thank y'all for playing. And tell you what I want to do, Alexis, I actually just got finished looking at some of your work online. So are you still working on that quiz, the quadratic functions quiz?
Yeah, I still gotta work on it.
All right. Now, are you familiar with the graphing calculator in Edgenuity?
Not really.
All right. Give me a second, guys. I'm going to try to share my screen so we can go to Edgenuity together and take a look at something that will be a benefit to both of you, actually. So let me make sure I do this right. Let me take my time. I'm looking for Edgenuity. There we go. Okay. Now what I need to do is get inside of the lesson. I'm not sure if I can do that or not.
I have a question.
Go ahead.
What if I finish early?
If you finish your class early?
Yes. Like if I finish the class.
Yeah. When you finish the class, I have to certify that it's been completed, and then I can move you on to the next class, which for you is going to be the B part of your class. That's what we want, actually. Now, we want you to finish part A in anywhere from 9 to 13 weeks. And then once you're done with part A in those 9 to 13 weeks, let's say you finish in 13 weeks, right? Then you'll have 5 weeks left this semester to start working on part B of the class, which will allow you to finish part B the early part of next semester. Does that make sense?
Yes.
Yeah, and that conceivably would allow you to finish more than one math credit every academic year. You should at least be able to finish 1.5 credits. If you move a little faster than the 13-week pace and can finish in 9 weeks, then you might be able to complete 2 full credit math credits in a semester.
Okay, let's say I finish both of them. Do I also go to another class, right? I also get more and more.
Yeah. Every time you finish a class now, I look in and make sure everything is kosher. I give you another class. And let's say you finish all of your math credits, then what you may end up doing during this block is you'll start working on another set of credits that you'll need, and they may move you from my class to the class of the teacher who is in that content area. But yeah, it's a very fluid situation now. I'm here with you to walk you through the math part of your journey, and once the math part is finished, then we get you on to the next thing that you need to do. This is all designed to help you graduate quickly, on time, and both, if both are achievable. But definitely you're allowed the opportunity to graduate quicker by being able to complete multiple courses in a semester. Did that answer your question?
Yes.
Okay. Alexis, what I want to show you, I may be able to find online. And then what I'll do is take a screenshot of it in Edgenuity so I can show it to you. All right. You can both still see my screen, right?
Yeah.
Okay, good. All right. So I am spitballing here. I have never used this graphing calculator, but it actually looks like it's as good as any other. So Alexis, when you're working with functions, especially quadratic functions,
Yeah.
it is useful to be able to see what they look like, and that will help you answer questions about what the functions do when there are other numbers involved in the equation. Let's take an example here. Now I'm going to do x squared. Now see how every time I type something, it actually draws a picture of it for me?
Yeah.
All right, so see, that is now the graph of x squared. I'm going to add to it x squared minus 4x plus 4 is equal to 0.
Alright.
Yeah, I didn't want to do all that. I just want to show the function first. Okay. All right, can both of you take a look at this now? Tell me what the value is of x at the point that I am touching right now. What is the value of x?
2.
All right, and then what is the value of y?
0.
All right, good job. This point is called the x-intercept of the graph. It is the point at which, no, it's the y-intercept. It's where y is equal to 0. This is the y-intercept. The point at which y is equal to, y is equal to 0 whenever x is equal to 2. Now, this point is called the x-intercept. It is the value of y whenever x is equal to 0. Do you see that?
Yeah.
All right. Now, I'm going to go out on a limb and say it's much easier to see when it is graphed than it is to see when you're looking at that equation. Does anybody agree or disagree with what I just said?
Agree.
All right. Now let's take a look at the function now, because we already know what the graph has shown us. But if you look at that function and I make x equal to 0, what is y going to be equal to? Let's write it like this. Y is equal to x. Let's say x is 0. That's going to make this term go away, right?
Yeah.
And then this term is going to go away. And then what am I left with? If x is equal to 0, what is y equal to?
0.
No. If x is equal to 0, what does y equal? If x is equal to 0, this term goes away, this term goes away, but this term is still left. So if x is equal to 0, what does y equal?
4.
Yeah, remember the graph now. See, when x is equal to 0 here, y is equal to 4. The same thing that the graph says is consistent with what the equation says. If I plug in x is equal to 0, that goes away, y is equal to 4.
Yeah.
All right, now if I want to see what happens when y is equal to 0, the graph tells me x is equal to 2 at this point. So let's make x 2. X is equal to 2. What's 2 squared?
4.
All right, and then what is minus 4 times 2? Minus 4 times 2.
8.
It's minus 8. Minus 8. All right, so far I have 4 minus 8. Now what's 4 minus 8? Not 8 minus 4. Now what's 4 minus 8?
Minus 4.
All right, so I've got minus 4 here, plus 4. So what's minus 4 plus 4?
16.
No. Minus 4 plus 4.
Shit, I don't know.
No, here, watch now. Look at the graph. I'm at minus 4, and plus 4 says I'm moving 4 steps to the right. So I'm minus 4, minus 3,
0.
minus 2, minus 1, 0. Minus 4 plus 4 is 0, right?
Yeah.
All right, because see, the graph tells us that when x is equal to 2, y is equal to 0. And the equation tells us the same thing. When x is equal to 2, y is equal to 0. See that?
Yeah.
All right, so what did I want you to get out of that? Whenever you're dealing with functions and questions about the functions, a graph is going to help you get where you're going. Now, when you are inside of an Edgenuity lesson or a quiz, you're going to see a graphing calculator that looks so much like the one I'm showing you, it's probably the same one.
Yeah.
But the way it works is you type your equation over here and it will graph the equation over here. If you want to type more than one equation, you can click here and add equations, and each equation you add, it will graph them. When you're starting out with this though, stick to one. Just stick to one equation so that it gives you an idea of what the functions look like, and that makes it a lot easier to answer questions about those functions.
Yeah.
Now, did I just tell you something?
Yes.
Do you notice that every time you come on here, I tell you something?
Yeah.
I don't know what that tells you, but that tells me I must know what I'm talking about. I'm joking.
Yeah.
I'm joking, man. But yeah,
Mm-hmm.
that should help you. And let me know when we see each other next if you are able to find that graphing calculator in Edgenuity, because it'll probably be easier to use inside the tool you already have, as opposed to trying to open two different windows like the one that I just opened. You don't want to have to work in two different windows like that.
Yeah.
All right. So if both of
All
you
right.
gentlemen are clear of heart and mind, now we can go ahead and sign off today. We've had a good session. Luis, you've gotten to see the introduction and what it looks like for somebody who's been with me for a few weeks. It does not change, man. We have fellowship and we try to clarify and illuminate math to help you keep moving. And we always have time to talk about the questions that you asked about, hey, how do I progress through this thing? And what if my pace is fast enough where I finish with a class? This is what we want to use this time to do. We want to get to know each other and get better at what we are doing, and make sure that all the time we spend together is meaningful and productive. See what I'm saying?
Yeah.
All right, so
Yeah.
hopefully I will see both of you gentlemen tomorrow, and we'll be joined by some of your other classmates. But until then, y'all take care, and I'll see you soon.
All right.
All right, take care, Luis.